All right, let's jump right into this. Today's explainer is diving into an absolutely fascinating computational experiment called the IM9 cancer simulation. It's a thought experiment for sure, but it's a deeply profound one that basically asks us to look at the microenvironment of our bodies in a completely new way. We're going to explore what actually happens when we stop treating illness merely as something that just has to be annihilated with brute force, and start looking at it as a biological system that's somehow lost its ability to communicate.
We've got a lot of ground to cover in this explainer, so we're going to break it down into 6 clear steps. The paradigm shift, the rules of the simulation itself, how we empower healthy cells, finding that crucial balance point, the hidden power of randomness, and finally, why focusing on systems beats pure eradication. Let's get into it.
Section 1. The paradigm shift. To really grasp what this simulation is doing, we have to rewind a bit and look at the underlying philosophy driving our typical approach to disease.
Mainstream treatments usually rely on what's essentially a search and destroy mission, right? As you see on the left, we cut, we burn, or we poison a tumor until ideally all the malignant cells are gone. And hey, that's effective in a lot of contexts. But the systems theory view on the right, it asks us to look at the whole microenvironment. It focuses on the innate ability of the organism to maintain order. It kind of suggests that maybe total destruction completely overlooks the power of healthy cell adaptation and systemic memory.
So this entire simulation is anchored in what the researchers call the IM9 philosophy. It's a framework that divides life into these really interesting triads. You've got 3, which is initiation. Think of it as the seed stage. You have 6, which is circulation, or basically repetition without any resolution. And then you have 9, representing full integration and coherence. In this view, illness isn't just a foreign invader. It's a system trapped in a repetitive 6 loop.
And this is exactly how we can view cancer in this model. It's that trapped 6 loop. It's not just uncontrolled growth. It's a severe, fundamental breakdown of communication within the living cosmos of our bodies. Normally, healthy tissues are constantly sending regulatory cues. Grow here, stop here, die here. But in the trapped 6 loop, cancer cells just cease responding to those cues. They stop listening to the system entirely and become completely self-referential, endlessly circulating and replicating without ever reaching resolution.
Okay, moving to Section 2, the simulation rules. Let's see how the researchers actually turned this philosophy into a mathematical, computational experiment.
Imagine a digital arena. We have a 2D tissue grid, 40 by 40 sites, and each site is either healthy, cancerous, or dead. The cancer cells attempt to convert adjacent healthy cells with a fixed probability. But here is the kicker for the baseline scenario. Initially, the healthy cells have absolutely zero active defenses. They're sitting ducks. They simply become cancerous if contacted. So naturally, a single cancer cell rapidly colonizes the entire grid because it's a completely unfair fight. Now, to intervene, the model introduces a wand. Think of this wand as an external therapy delivering random surges of stimuli, kind of like a highly targeted medical cattle prod. When this wand activates, it leads to one of 4 very specific outcomes at each time step. It might literally kill the cell, it could reprogram it, reverting it back to a healthy state and fixing its signaling. It might cause a division disrupt, momentarily blocking it from replicating, or it might have no effect at all and the cancer just continues. Just look at the sheer granularity of the output in these data tables. The simulation didn't just spit out a broad summary at the end. It tracked incredibly specific step-by-step outcomes. We're talking every single conversion, every resisted attack, every dead cell, and every reprogrammed cell across dozens of steps. But notice the result here. Even with that wand firing away, just introducing destructive force wasn't enough to prevent the cancer from dominating. The disease still outpaced the destruction.
Which brings us to Section 3, empowering healthy cells. This is literally the turning point of the whole experiment, because introducing the wand alone was a losing battle. They needed to change the rules of engagement entirely.
The researchers pivoted and asked a brilliant, fundamental question. What if these healthy cells weren't just passive victims? What happens to the entire system if we give those healthy cells agency and the actual ability to fight back? So they started arming the healthy cells with 3 powerful new tools. First up, resistance. If exposed, they suddenly gained a probability of fighting off that conversion. Second, active influence. They were allowed to actually kill or reprogram the adjacent cancer cells themselves. And third, and this is the absolute game changer, memory. When a healthy cell encountered cancer, it gained memory from that specific interaction. And that memory cumulatively increased its resistance and its influence over time. Check out this chart. It's absolutely striking. Notice that blue line at the top? That's scale 1.0, the baseline where healthy cells have no power and cancer runs rampant. But as you follow the lines moving down towards scale 2.0, where healthy cells are getting more and more empowered, that exponential curve of the cancer spread gets visibly, undeniably suppressed, giving the healthy system agency literally flattens the curve of the disease.
Let's put some hard numbers to this, because increasing destructive force alone had a very limited impact, but amplifying the healthy cell's ability to resist and remember produced these massive, nonlinear benefits. Look at the base scale 1.0. Peak cancer hits over 1,100 cells and you're left with a measly 22 healthy cells. But drop down to scale 2.0. Peak cancer is practically cut in half to 607. The total resisted conversions more than double, and the final healthy cell count jumps to 153. Empowering the healthy system changes the entire landscape.
Section 4. Finding the balance point. This sweep of the scales actually led the researchers to a highly specific, fascinating discovery right in the middle of that data. Because, while scale 2.0 was great for wiping out cancer, real biological systems rarely operate at maximum extremes.
So what happens when the scale reaches exactly 1.6? If 1.0 is total cancer dominance and 2.0 is heavy eradication, what kind of weird dynamic emerges right there at a scale of 1.6?
Well, right around that 1.6 mark, we hit this incredible sweet spot, an unstable equilibrium. If you trace the cancer line and the healthy cell line on this chart, instead of one completely wiping out the other, they find a dynamic balance. The cancer growth plateaus and the healthy cells hold their ground. They create this fluctuating but ultimately stable ecosystem right there on the grid. This strongly suggests that a highly meaningful level of disease control might be achievable without total destruction. It perfectly mirrors chronic management rather than this volatile pursuit of an immediate cure. In this balance run, the cancer maxes out around 700, while healthy cells maintain a solid presence between 70 and 120. You don't achieve total eradication, sure, but the absolute most dangerous aspect of the disease, its uncontrolled exponential expansion, is entirely stopped in its tracks.
Section 5. The power of randomness. Now, there is a secret ingredient here that kept the cancer cells from simply evolving a workaround to the healthy cell's new defenses. Something the wand was doing proved absolutely critical.
Unexpectedly, the key was randomness. Introducing random, varied surges prevented the cancer from ever adapting to a steady rhythm. Think about it. If the therapy was totally predictable, the cancer would just adjust and keep growing. But by varying the wand's effects unpredictably, it constantly knocked the cancer off balance. That unpredictability was a vital tool because it created the literal windows of time needed for the healthy system to learn and build memory.
Scanning the raw data here, we can see exactly how those high-intensity bursts created physiological breathing room. Whenever that random surge toggles on, look at the mean healthy memory column. It steadily climbs. The chaos introduced to the cancer gave the healthy cells the exact space they needed to adapt, remember, and ultimately stabilize their environment.
Finally, Section 6. Systems over eradication. Ultimately, what does a computational toy model on a digital grid teach us about real, infinitely complex human biology? It brings us right back full circle to that IM9 philosophy. It suggests that healing might actually be about restoring communication and coherence, rather than just purely eradicating the loop. It moves us out of that 6 state of isolated self-referential disease and into the 9 state of true coherence, where the whole supports the individual cell and the individual cell supports the whole.
So, I'll leave you with this. How does this shift your view on managing chronic disease? Is creating a dynamic, educated balance actually more powerful than seeking an immediate, destructive cure? It's a pretty profound thought. If small, compounded improvements in healthy cell adaptation, communication, and memory can completely alter the long-term balance of an entire system, maybe the future of medicine isn't just about fighting the disease. Maybe it's about aggressively teaching and supporting the health that is already there. Something to really think about as we keep exploring the incredible complexities of the human body.